We'll start in 1 minute. In a few minutes, we'll start section 3.2, part C, on applications of slope and parallel and perpendicular lines. But first, we'll finish a couple of problems from yesterday's lecture. Okay, so this first problem, part 1, find the slope and the y-intercept of the line 4x minus 3y equals 6. Okay, so first let's find the y-intercept. So every y-intercept has an x-coordinate equal to 0. So when x equals 0, replace x in that equation with 0, and we're left with negative 3y equals 6, or y equals negative 2 when we divide both sides by negative 3. Okay, so the y-intercept is the ordered pair 0, negative 2. Okay, 0, negative 2. Okay, to find the slope of the line, we need another ordered pair. So let's go ahead and find the x-intercept. That will give us another point. So every x-intercept has a y-coordinate equal to 0. When y equals 0, we replace the y-coordinate with 0, the variable y with 0, and we're left with 4x equals 6. And when we solve this for x, we divide both sides by 4. 6 divided by 4 simplifies to 3 divided by 2. So the x-intercept is the ordered pair 3/2, 0. Okay, now we'll apply the slope formula. I'll remind you of the slope formula. M equals y2 minus y1 over x2 minus x1. So we're using these ordered pairs. So in the numerator, I'll write 0 minus -2. And then in the denominator, 3/2 minus 0. 0 minus -2 is 0 plus 2, or 2. And 2 divided by 3/2, that's equal to 2 over 1 multiplied by the reciprocal of 3/2, which is 2/3. And so the slope of the line is 4/3. Okay, in part 2, it says solve this equation for y. So I'll rewrite 4x minus 3y equals 6. To solve this equation for y, we can do it in 2 steps. So first, subtract 4x from both sides, and we'll write it as -3y equals -4x plus 6. Then divide every term on both sides by -3. -3y divided by -3 is y. -4x divided by -3 is positive 4/3 x. And 6 divided by -3 is -2, so we write -2. Okay, then to graph the line, we have 2 ordered pairs. We have the y-intercept, 0, -2, and the x-intercept, 3/2, 0. 3/2 is just 1.5. So we'll squeeze the graph in. 0, -2. And the y-intercept the x-intercept is 3/2, 0. And then we can graph the line. Okay, when you look at this equation, y equals 4/3 x minus 2, this is a special form of a linear equation, which we will talk about more in the future. But notice when we solve for y, the coefficient of x is the same number as the slope. 4/3 is the slope. And the other number, think of this as -2. That's the same number that's the y-coordinate of the y-intercept. And that makes sense because when you replace x with 0 in this equation, you're left with y equals -2. Okay, so we'll talk more about this form later. Okay, let's graph the lines x equals 6 and y equals 1. We've discussed lines like this. What kind of line is x equals 6 in the xy plane?
6 and 0.
It's a vertical line. Every point has the same x coordinate of 6. So the variable y is missing. So that means y could be any number as long as the x-coordinate is 6. So I'll pick a couple of points where the x-coordinates are 6, and we can pick y to be any numbers we want. So I'll pick -2 and 3. Okay, so when we plot those ordered pairs, I'll write them as ordered pairs. The ordered pair 6, -2, and 6, 3. So 6, -2 is right there. 6, +3. And then the straight line is vertical. And the equation for that is x = 6. To graph y = 1 in the xy plane. So this time, the x-coordinate can be anything as long as the y-coordinate is +1. So we'll find a couple of points. So I'll pick x to be -3 in one case and +4 in another. So we have the ordered pairs -3, 1 and +4, 1. So let's plot -3, 1 and +4, 1. And draw a straight line through those 2 points. This line is horizontal. And the equation in particular is y = 1. Okay, the next problem, use the most convenient method to graph y = -1/4 x + 2. Well, we might argue about what the most convenient method is. So you get to decide. So I think what I'll do is I'll find the y-intercept. When x is 0, the y-coordinate is 2. That's the y-intercept. And we can find another point, or we can use the slope. Oh, I'm sort of getting ahead of myself, but this number, -1/4, is the slope of the line. In a few minutes, we'll talk a little bit more about this. So anyway, another convenient point for x is 4, because when I multiply -1/4 times 4 and then add 2, -1/4 times 4 is -1, and -1 + 2 is +1. So another ordered pair is 4, 1. Okay, so we can plot those 2 points. 0, 2, and and positive 4, positive 1. Okay, then 2 points are all you need to graph the line. Okay, in the next section, well, it's chapter 3, section 2, part C. It's more of the same. Okay, but we get a little more information about what I've mentioned briefly. So the slope-intercept form, this is one of the forms of an equation that you want to make sure you're familiar with, the slope-intercept form. The equation of a non-vertical line in the xy plane can be written in the form y equals m times x plus b, where m is the slope, it's the slope of the line, and the ordered pair 0b is the y-intercept. So if you have an equation of a straight line in standard form, like ax plus by equals c, solve that equation for y, and it will be in the slope-intercept form. So once again, the nice thing about the slope-intercept form is the coefficient of x, the number that's in front of x, is the slope of the line, and the number over here that you're adding is the y-coordinate of the y-intercept. Okay, so rewrite the following linear equations so that they are in slope-intercept form. So in other words, solve each of the equations for y. So if I begin with 2x minus 3y equals negative 6, first subtract 2x from both sides. And when we do that, we'll get negative 3y equals negative 2x minus 6. And then the next step, divide every term on both sides by negative 3. Negative 3y divided by negative 3 is y, positive 1y, or just y. Negative 2x divided by negative 3 is positive 2/3 times x. And negative 6 divided by negative 3 is positive 2. So let's identify the slope of this line while we're at it. Since we solved the equation for y, the coefficient of x is the slope. So the slope is 2/3. And the y-intercept has an x-coordinate of 0 and a y-coordinate of positive 2. So you remember yesterday, this is enough information to graph the line. If we know a point and the slope, we can graph the line, like what we did yesterday. Okay, in the next equation, rewrite this in slope-intercept form. That means solve this equation for y. So step 1, subtract 2x from both sides. That leaves us with 8y equals negative 2x plus 16. Then divide every term on both sides by 8. 8y divided by 8 is y. Negative 2x divided by 8 simplifies to negative 1/4 times x. And positive 16 divided by 8 is positive 2. So let's identify the slope. The slope is negative 1/4. And the Y-intercept is the ordered pair 0, 2. Okay, the next part. Two lines are parallel if they have the same slope, but different y-intercepts. So these two lines are parallel lines. The slope of the line on the left, what's the slope of that line? Two is the coefficient of x. We've solved for, it's already has y by itself, so the slope is 2, or you can think of it as 2 over 1, rise over run. And the y-intercept is the ordered pair 0, 1. For the other line also has a slope 2 over 1. It's okay to just list the slope as 2, but remember how to interpret that as rise over run. And this time the y-intercept, when x is 0, the y-coordinate is 3. Okay, two non-vertical lines are perpendicular if their slopes are negative reciprocals. So here's an example of two lines that are perpendicular. The slope of this line is in slope-intercept form. The slope of this line is negative 3/2. The slope of the other line is positive 2/3. So we just note that the numbers negative 3/2 and positive 2/3 are negative reciprocals of each other. I'll just write are negative reciprocals. So in case you're uncertain about the word reciprocal, first I'll write the reciprocal of I'll just pick a different fraction. The reciprocal of 3/5 is 5/3. So you just interchange the numerator and the denominator to find the reciprocal. But perpendicular lines have slopes that are negative reciprocals. So you have to remember that one of the slopes is negative and the other one is positive. Okay, the next page determine if the pairs of lines are parallel, perpendicular, or neither. So I think in my opinion, that the best way to determine if two lines are parallel, perpendicular, or neither is to rewrite each of the equations so that each one is in slope-intercept form. And then all you have to do is compare the slopes. So I'll just write that as a procedure. Write each equation in the form y equals mx plus b. Okay, the y equals mx plus b is the slope-intercept form. So in other words, solve each of those equations for y and then compare the slopes. Okay, I'll rewrite this equation, 5x plus 4y equals 20. Solve for y. First, subtract 5x from both sides. So we get 4y equals negative 5x plus 20. Divide every term on both sides by 4. 4y divided by 4 is y. And negative 5x divided by 4 is negative 5/4 x. And 20 divided by 4 is 5. Okay, so the slope is of this line is negative 5/4. Okay, now solve the other equation for y. I'll rewrite it 4x minus 5y equals 20. Subtract 4x from both sides, so we get negative 5y equals negative 4x plus 20. Then divide every term on both sides by negative 5. Negative 5y divided by negative 5 is y. Negative 4x divided by negative 5 is positive 4/5 x. And 20 divided by negative 5 is negative 4. Okay, the slopes are negative reciprocals. So that means the two lines are perpendicular. Because the slopes are negative reciprocals. Perpendicular, I guess. So what are perpendicular lines? Maybe we should talk about perpendicular lines for a second.
Cross.
They what?
And cross each other.
They do intersect, but even non-perpendicular lines will intersect if they have different slopes. So if two lines form right angles, then they are perpendicular. So my graph is sort of off, but you know what it means to be perpendicular. So two lines are perpendicular if they form right angles at the intersection. Two lines are perpendicular if they form right angles when they intersect, 90-degree angles. Okay, so as long as neither of the lines is perpendicular, as long as neither of the lines is vertical, if two lines are perpendicular, one will have a positive slope and the other one will have a negative slope. Or, as we've already claimed, the slopes of perpendicular lines are negative reciprocals. Okay. What about parallel lines?
They never intersect.
Yeah, parallel lines have the same slope but different y-intercepts. So they run alongside each other, which is the meaning of parallel when it's translated from the original languages. So parallel lines have the same slope, and they never intersect. Okay, let's move on. The next example of the next pair of equations determine if the two lines are parallel, perpendicular, or neither. So we'll rewrite each equation in slope-intercept form. In other words, solve for y. So 3x minus 4y equals -1. First, subtract 3x from both sides, and we get -4y equals -3x minus 1. Then divide every term on both sides by -4. -4y divided by -4 is y. -3x divided by -4 is 3/4 x. -1 divided by -4 is positive 1/4. So the slope of this line is positive 3/4. Okay, then solve the other equation for y. -6x plus 8y equals -6. So this time we add 6x to both sides, and we get 8y equals 6x minus 6. Then divide every term on both sides by 8. We get y equals 6x over 8, or 3/4 x. And then minus 6 divided by 8, which is also 3/4. The slope of this line is also 3/4. So that means the two lines are parallel. They are different lines because they have different y-intercepts, but they have the same slope, so they are parallel. Okay, the next pair of lines, 2x plus 5y equals yeah, in my paper it looks like -10, but I think it's supposed to be equals. So something was haywire with the printer, I think. So 2x plus 5y equals 10, and 3x minus 4y equals 12. Solve each equation for y. So this one, subtract 2x from both sides. 5y equals negative 2x plus 10. Then divide every term on both sides by 5. We get y equals negative 2/5 x plus 2. The slope of this line is negative 2/5. Solve the other equation for y, subtract 3x from both sides, and we're left with negative 4y equals negative 3x plus 12. Divide every term on both sides by negative 4, and we get y equals positive 3/4 x minus 3. The slope of this line is positive 3/4. Okay, so the slopes are not the same, and the slopes are not negative reciprocals of each other. So the two lines are not parallel and they are not perpendicular. So we'll just say neither, by which we mean neither parallel nor perpendicular. Okay, the two lines do intersect. So in general, when two lines have different slopes, they always intersect at exactly one point. So that is something that we'll learn more about later this semester. Okay, here's a problem. Find the slope-intercept equation of the line that passes through the point 0, negative 2, and that is perpendicular to the line y equals 2/3 x plus 1. The slope of the given line is 2/3. So I'll make a note of that. The slope of the given line is m equals 2/3. Right, this equation is the slope-intercept equation, y equals 2/3 x plus 1. So the coefficient of x is 2/3. That means the slope is 2/3. Okay, so a line perpendicular to the given line has what for a slope?
-3/2x.
Negative 3/2. No variable, just negative 3/2. A line perpendicular to the given line has slope m equals negative 3/2. Okay, so this line that's perpendicular to the given line, it has a slope of negative 3/2, and it passes through the point 0, negative 2. So what point is that, 0, negative 2?
Y-intercept.
It's the y-intercept of that perpendicular line. So we note Since that perpendicular line passes through 0, -2, we recognize that as the y-intercept. How do we know it's the y-intercept?
The x-coordinate is 0.
Because the x-coordinate is 0. Remember, see how that little piece of information keeps coming back? Every y-intercept has an x-coordinate of 0. So the point whose coordinates are 0, -2, that is the y-intercept of the perpendicular line. Okay, so we know the slope of the perpendicular line and we know the y-intercept. So we can write down the slope-intercept equation, y equals mx plus b. So in particular, y equals what for that perpendicular line?
-3/2x minus 2.
Yeah, -3/2 times x minus 2. So that wasn't too bad. The ordered pair 0, -2 is the y-intercept, so the y-coordinate is the number -2. So we're done. That's the equation of the line that's perpendicular to the line y equals 2/3 x plus 1. And that perpendicular line passes through the point 0, -2. Okay, let's move on to the next page. We have some applications. Not all equations will have the variables x and y. So here's an example. We have a linear equation in the variables g and c. So in the linear equation, c equals 28 times g plus 450. C represents the cost in dollars to accommodate G guests. So this equation is in slope-intercept form. So what's the slope? So we're not looking at y equals mx plus b. We're looking at something that has different variables. C equals 28g plus 450.
Would 28 be the slope?
Yeah, the slope is the coefficient of g. Think of that as 24/1. But this slope has units. Remember, let's just look at this as a way to remember y equals mx plus b. And the slope, if you have two ordered pairs on that line, you could write the slope as y2 minus y1 over x2 minus x1. Okay, so what takes the place of x in this equation? Instead of y equals mx plus b, we have the form c equals mg plus 450. So instead of y, we're using c, and instead of x, we're using g. So the numerator, 28, could be thought of as C2 minus C1, and the denominator could be thought of as G2 minus G1. Okay, but what are the units of C? And what are the units of G? Well, we're told C represents the cost in dollars. And we're told that G is the number of guests. So the units for the slope are dollars per guest. So the way to interpret the slope of the line, we could say the cost I won't write it all down, the cost in dollars to accommodate G guests. So the cost increases by $28 when the number of guests increases by 1. Okay, so I'll just say one or two more things about this. If there are 0 guests, then the cost to get everything set up is $450. Right? If you're going to accommodate guests, even before they arrive, you have to spend money to get things ready, right? Like the startup costs. And then if you have 10 guests, then the total cost will be 28 times 10 plus 450, and so on. So this is just a cost equation for accommodating G guests. But it's a linear equation. Okay, let's move on to the next example. In the linear equation, capital P equals 0.575 m plus 42. P represents the amount a driver is paid each day for driving m miles. So we'll assume that the driver is paid in dollars. Okay, interpret the slope. Okay, the slope is 0.575 over 1. So if we had 2 ordered pairs, the ordered pairs wouldn't be of the form x comma y in parentheses. They would be in the form m comma p in parentheses. So the slope, we can determine the units of the slope if we imagine that we have, instead of y2 minus y1, we have p2 minus p1 divided by m2 minus m1. Okay, we're told that P represents the amount a driver is paid. We're assuming he's paid in dollars. And M is the number of miles. So what are the units of the slope in this case? So in the numerator, we have P values. How are we measuring P? We're assuming dollars, right? Because P represents the amount the driver is paid. So the units of the numerator is dollars. And what's the unit of the denominator?
Miles.
Miles. Okay, so the driver is paid an additional $0.575, or you could say 57.5 cents for each additional mile driven. Okay, we have a couple of minutes left. So this one won't take too long. We might not finish it all, but this one says a caterer charges $12 per dinner plus a $30 service charge for catering. If C is the total catering charges in dollars and D is the number of dinners prepared, then this linear equation, C equals 12 times D plus 30, represents the amount of the total catering charges. Okay, so find the total catering charges if 8 dinners are prepared. So that's like saying this: find the value of C when D is 8. So just replace D with 8 and do the arithmetic. 12 times 8 is 96, and 96 plus 30 is 126. So the total catering charges would be $126. Okay, we're out of time, so go ahead and sign in for attendance. And Victor. Nicholas. Melissa and Richard. That's it.